Now the cross product involves doing the determinant operation 3 times. So given two vectors, u and v, with their components, like I've got them there, understand that the cross product of two vectors is another vector, right? Not like a dot product. A dot product, you get a scalar when you do a dot product. When you do a cross product, you get another vector. So we're starting with three component vectors. The cross product will be a 3-component vector. Right? Define the first component. I always write my vectors in component form, lined up like this, so that I can do this. Right? Define the first component of the cross product, cover up the first component, and do the determinant with the components that are left. U2 times V3 minus U3 times V2. That's what this is right here. It's just that determinant operation using the other 2 components. Okay. Define the second component, cover up the second component, and do the same thing. U1 times V3 minus U3 times V1. Only thing being, for the middle component, there is a negative in front of it. It switches signs. That is part of formula. Okay, and then the last, define the third component of the cross product, cover up the third components, and do the determinant. U1 times V2 plus V minus V2, U2 times V1. That's this one right here. So remember when we did dot product, we used the dot in between, which we use as a multiplication symbol when we're just dealing with numbers, right? And now when we use cross product, we use an X, which kind of looks like multiplication also. Neither one is really multiplication, right? We don't have multiplication. We have only scalar multiplication of vectors, right? And the important thing is the cross product of 2 vectors is another vector. It's not a scalar.